Good afternoon, everyone, or good evening. Right now we'll have Robert Raposa give a talk about not missing the event bus. The talk is for 45 minutes, and we'll have 10 minutes for Q&A afterwards. And please give a warm welcome.
Mic's on. My name is Robert Raposa. I'm here to represent the more immediate work of the team that I work on, the Arc Bomb Squad, and also represent lots of work by many other people that came before this. You are here to not miss the event bus. I appreciate you taking the title seriously. Anyone who's not in this room, who knows? So what are we going to be talking about? First, why an event bus? And I'll also describe a little bit about the what. But really, why are we doing this? Current stop is the status of where we're at today. Then a little bit about how to get on the bus, a little bit about how to use it safely or ride along safely, and then what's coming next, and then some time for additional questions. All right, so why an event bus? Actually, what? We're going to start with the what, but I want everyone to hold in mind the why question, because it's really, why are we doing this? So starting with this, if you're communicating across OpenEdX services, then you may or may not have known this, but the event bus is your new friend. And I want you to remember that anytime you're thinking, oh, we need to communicate across OpenEdX services. How should we be doing this? Not the way we used to. And this is a picture from the Hooks framework. I don't know, some of you might have heard this term, the Hooks framework, not heard it. There's resources at the end with links to documentation. But basically, the Hooks framework is a method for extending our platform. And it's based on two different things. I've got events and filters. We're talking about the event bus, so we're just going to be talking about events here. And this is an image of, we have a particular service. You may define certain events that get fired off when certain things happen. I'll go into an example soon about grades changing. That event gets fired, and we're using this technology called Django signals within Django to send an event, receive that event, and then those are meant to be plugs. So you could have plugins that receive these events and plug into the service and add in some new functionality based on the events that are getting fired. And the Hooks framework defines a whole bunch of things around how this works, defines what's called the OpenEdX public signal, which is a class that's used. And this is all happening in process within the service. If you wanted to do some bigger processing of this event while in that service, you would probably spin off an async task within like Celery. For those, Celery is another technology that we use for doing asynchronous work within a service. So here's where the event bus comes in. The event bus was built upon this technology, so we already have these events defined. We actually have a bunch of events defined at this time that are being fired from various services, but probably mostly from the LMS and Studio. And the way this works is that same signal just gets serialized onto the bus, shipped over to whatever services want to care about that particular event. And on the other side, we use the same exact pattern. So the same signal will be sent. You can listen to that signal and happily use that event within another service. So here is what happens today, pre-event bus, in many different places in our architecture. So as I described, LMS is one of our services. This grade changed event, as an example, would fire an asynchronous task that goes to the LMS worker. So this is based on the technology that I just mentioned, Celery. It's a separate service, or it's a separate process. So it's asynchronous, but it's all within the LMS service. And then we make an API call to some other service, like the credentials service. And we literally have code within the LMS, within the edX platform repository, that is run within the LMS worker that uses a method named something like grade is interesting to credentials. I don't remember the exact method, but so what are the problems here? Several problems. One is the whole idea of bounded context, and which comes from domain-driven design. So basically, the whole concept of what grade is interesting to credentials has now leaked into the LMS service. So the LMS needs to know when something is interesting to credentials, but it's not interesting at all to the LMS. And that is not a great thing. Then we've got these direct API calls to credentials, which both leads to very tight coupling. So the LMS service needs to know precisely that that the credential service cares about something so that it can call to it. And then if there's any problems with the credential service, if the credential service needs to go down for a little bit or take some downtime, all of a sudden that is a LMS problem because the LMS worker is trying to call and send data over. So a variety of problems with this architecture. So here's what happens with the event bus. The event bus, instead of grade change if interesting to credentials, instead we have this grade changed event that the LMS just sends over to the event bus, and now we've got a credentials consumer that can consume this whenever it wants. If it needs downtime, it takes some downtime, takes a little nap, wakes up. Those events are still waiting for it on the event bus for whenever it needs. Then credentials can do whatever it needs to do. And then we have, so the bottom of this is a new possibility that doesn't exist in the old system, which is I've got some other service that loves grades, and it wants to do something based on the grade changed event. All of a sudden, it can do that, and nothing new has to happen on the LMS side. That event is already produced, it's already waiting, and it can just start consuming the events as well. Yeah. So some additional details. So I talked about the loose coupling, the clear bounded context, also allows for data redundancy more easily within systems. I talked about how the extensibility and the communication being more resilient. This is pseudo categorized under like more features quantity and more types of features quality, but the point I want to make here is the community has lots of different needs out there. For many deployments of the OpenEdX platform, you're probably small enough where you're not necessarily concerned with, I want lots of services and I want, all this communication. So what's in it for you? So what's in it for you is from a development perspective. We have also lots of development teams within my organization, to you, edX, and then across the community. And this allows each development team to focus more clearly on their domain, credentials, whatever it is, and be less concerned with other services. And that enables you to potentially add more features, which you then benefit from, even though you may not love the additional infrastructure. And so this last point, eliminate expensive delayed batch synchronization, I will be going into shortly in terms of that benefit. So these are all reasons why an event bus has helped so many other architectures and companies, and nothing's new about it. It's just new to us because we have finally invested in having it available to us. So where are we at now? So step back. Where were we last year? So this is slight historical perspective. We had worked on a happy path of an enterprise use case with an event within 2U edX. Happy path meaning we weren't dealing with error cases, exceptional cases, anything like that yet. We had selected Kafka. We chose Confluent as our hosting provider for Kafka. Avro is a technology that we selected for serializing and deserializing these signals onto the bus, which is all sort of behind the scenes things that you probably don't need to know about unless you're going to do a whole new implementation of the bus. And then getting the consumers spun up in containers for us in Kubernetes. We also laid the foundations for an abstraction layer, so it wasn't completed, but the whole idea being that multiple technologies could be used, not just Kafka, but if you read the OAP, OAP 52, which was in draft at that point, it describes this abstraction layer. Lots of people in the community wanted something like Redis, because Redis was already part of the platform, and this laid the foundations for having both a Redis implementation for other deployments and Kafka when you need it, for example, for us. So that's where we were. And then we also needed to take a little tack in terms of what our first event was going to be. So this is a picture of the event that we actually ended up working with. I'll give you a little bit more detail about this. And so this is what things looked like before our event. So we have, for those who are in the discovery talk, you would know a little bit about this, but we have this job called refresh course metadata, or RCM, and it is this Jenkins scheduled job that basically makes a call to a course discovery worker to go out to Studio. It actually goes out to the LMS, but it's grabbing all of the course information from Studio, bringing back all of the dates for all of the courses that we have. So it does a lot. And then it's processing all of that to do data redundancy, to like grab all that data, put it into discovery. And then based on some of that information, it may then make other calls off to e-commerce. And this is a very, very, very simplified view of what this job does. This job does many more things as well. But this is the part I want to concentrate on. I can use this, I forgot. This is where we're at now. So Studio, someone goes and makes an edit within Studio, and then the data changes. So a course data change event gets fired, goes to the event bus. Course discovery consumer can listen to these events, and then it actually ends up calling the legacy code that it is called from the same RCM job. So it is going into the same function that's doing the same things, and more on that later. And yeah, so now what happened when we, I would say, switched over? So we added this in. The RCM job is still running in the background as well, that large batch job. But here's the results of what happened. So with the scheduled job, I don't even know what the median latency was, because it was 4 to 12 hours when it was successful. Lots of times the job is not successful. Even when the job is somewhat successful, I think it's doing so much that it never gets to the tail end, and that is seemingly never successful. Now with the event bus, what you would expect. So under a second, you get data over from Studio to Discovery. So this is one of the people who helps our partners with, you're adding this data in and you're waiting to see this show up in the marketing site or something like that. And she was very happy. And you might look at this and ask the question, like, why did we wait so long? And so why did we wait so long to do this when the alternative at the time was to do these celery tasks and call APIs and run into a whole bunch of other sort of problems? Why did we wait so long to actually implement the event bus? That's another question, but it is something where, at least for us, the product teams had lots of things to do, and it was like, we'll use this when it is here, but we need to actually invest in having it here, and now we have it here, which is very exciting. So some other details about where we're at. So the OAuth moved from draft to provisional from the last time. We now have this fully functional Kafka implementation. There was this other OAuth about message formatting with cloud event headers, so things like message ID and the timestamp of the event from when it was actually fired, not like when it made to the event bus, and the host name from which it was sent. So all of these different headers are now passed along with the event. We've got error handling and audit logging, which mostly is just going to the logs. And we've got monitoring capabilities, replay capabilities that, for the most part, come with the fact that we're using Kafka, but we had a bit of implementation to do in order to actually move the offsets that are used for where to run from. But we can now replay events. This is the single event that we currently have in production all the way through. We've made more progress on the abstraction layer, and we've got a bunch of onboarding docs as well. And so this is just going to give a small taste of how to get on the bus, but for the most part, it's going to be check out the how-to and ask questions. So producing an event. The first thing I want to say about this is discuss with the owner. So right now, we are bootstrapping this whole process. So you can imagine sometime down the line, it's like, oh, I want to do a thing based on the platform and I want to extend it. Let me look at this large suite of events that are already on the event bus and start consuming it and doing the thing that I want. At this point, they're not all on the event bus yet. So it is a slightly different picture. And so it is probably a consumer, though, that is like, it's not a producer saying, I just desperately want to start producing this for I don't know what reason. So it's a consumer that probably has something that they want to consume, and it's not yet produced, and it needs to be produced. So, so find out who the owner is, or if you are the owner of both, the consuming side and the producing side, great, more power to you. But that's often not the case in from where we are. So, so if you're consuming, talk to the producer owner. Make sure that you're designing an event if the event doesn't already exist. I should note that there are many events that do exist in OpenEdX events repository that are being sent, as I said, in process. So all of those could very quickly be sent onto the event bus. They're just not being done yet. And then next, one-time configuration this is per service. So there's just going to be a couple of settings that are required. Then the infrastructure is actually create this topic is where the events will actually land in Kafka. And then you'll write some code to send the event as a Django signal. As I said, that might even already exist. That's the in-process part. And then this later part is just write a very simple signal receiver that hears that this event fired and starts sending it onto the bus. Probably you'll use a rollout toggle so that you can turn it on once your infrastructure is there, and so that you don't have what happened the last time someone tried to do an event, which is, hey, I'm getting lots of errors because the topic wasn't yet created. So you'll do a rollout toggle. And one could imagine that even this simple signal receiver, I'm going to show you just for a moment code, could all just be config. Like there's nothing really complex about it, but for now there's a little bit of code. So this top part is the in-process signal, Django signal send event. So my event happened is getting sent. And then the bottom part is the receiver that I described that says, oh, I hear that my event happened. I see that my event is enabled, so I'm going to now send the event on the producer. That's all code that's lifted from the how-to that's linked from the slides, so you can see that whenever you'd like on Confluence. So now if I want to consume an event, one time per service again, configure the service. One time per service again, we're going to import this management command. And this is a management command that basically starts up an infinite loop. And the infinite loop basically pulls the event bus for events, and then it will take the signal and send that signal, so that then you could have a receiver that this bottom part, write the signal receiver that grabs that event signal and then does whatever, work your magic. So whatever you want to do based on hearing that actual event on the consuming side. And then code-wise, here's some code. The top part is just the line for running the management command that has the infinite loop, and then the bottom is the receiver. So writing safely. So some of this is just, somewhat fun war stories from like, hey, we've got one event, and now let's see what actually happens. So here is, I don't actually mean happy Django and sad Django when I say this, but what I mean is the one side is what Django expects. So Django's expecting this request response and does a lot of cleanup around requests and responses, and this infinite loop is not the typical expectation of Django. And so it took us a little while to learn that you could have a database connection problem that happens, and once it happens, it just sticks around because there's nothing that knows that it actually needs to reset the connection. So we actually had a couple of layers of fixes. The first one, because we actually had no idea what was happening, was simply, hey, if you have 5 errors of the same type, let's just restart our consumer. And this was a nice way of saying, let's just, basically, we found out that that would restore the connection. Everything would be happy after that. We had the 5 events that were unhappy for a little while. And then we have, as I mentioned before, the ability to just replay the events. So then we would replay the events, and that would clean everything up. But you didn't have to wait until that time to have all the other events be happy. They were starting off happy. Then we learned what the actual problem is. We now have database connection cleanup that happens when necessary, and and all is well. A note about this, though, is a reminder to think about the fact that it's different and we don't have actual requests and responses, and to like wonder, I've come up with a couple of scenarios where that it could impact people in my mind, but I will not promise to have come up with all of them. So one example is there's a concept of atomic requests. Basically, anytime the word request comes up, probably in the Django world, be suspicious about whether it's now working the way you expect, because we don't have these requests. So atomic requests, I was thinking about Dave's presentation with caching, and was like, oh, we've got a request cache, and that's not getting cleared yet. So that can very quickly be fixed, and I plan on fixing that. So those are some examples. So this, here's a question for the audience. Can anyone tell me the difference between the top picture and the bottom picture? So as it turns out, with the library that we are currently using, there is no difference between the top picture and the bottom picture. So if you are making calls to Memcache, or if you are making calls to a black hole, it's all the same as far as the library is concerned, and as far as errors or anything that you will get back. So this is just a little note of be careful on your Memcache setup until we complete this transition of libraries that's actually on backlog of some other team. And this is less about the event bus per se, but possibly because we're going to be setting up new consumers and new services that are trying to reach out to Memcache. Next one. So I love this little quote. It's idempotent when it works. So that was a quote that came up. So in order to be able to replay events safely, they need to be idempotent. And that means the ability to replay the full event and have it do whatever it was supposed to do again fully. And so in Studio, we've got this course data change event that I mentioned. It's now getting consumed by a course discovery consumer. But we found a problem because we're running legacy code, as I said, on the discovery consumer, and that hasn't all changed. So some of that legacy code says, oh, let me try calling out to e-commerce and giving a little update there. But that call is a direct to API call. So if the other little detail around this is it also says, I'm only going to do this if the data that e-commerce cares about changes. If it doesn't change, I'm not going to make this call. So if e-commerce is having a problem at the time that the first time it called, and then you try rerunning these events or whatever, it never fixes it because it's like, oh, that data is not changing. I already have that data in the database. So, so the right-hand side and the e-commerce call is all part of the legacy code. The obvious potential future solution, but will take some work, is, hey, let's get that on the event bus as well. So keep in mind that things like this will happen. We want to move towards actually idempotent processing of messages, and yeah, that's a note on that. Who wins this race? So this is a little note about the circular paths within discovery. So not pictured here is Publisher, which is a little interface that we use for a UI for adding marketing data into discovery to go out to our marketing site. And that marketing data needs to be attached to a course, and it's course data. So if that course doesn't yet exist, this Publisher interface is like, okay, that's great. We're going to call course discovery. Course discovery says, yeah, I'm going to add data to my database. I'm also going to call over to Studio to say, hey, we've got a new course, create it. Then Studio says, hey, course data changed for this event. That goes onto the event bus, just talked about course discovery consumer, goes into this legacy code. It says, oh, I'm going to create a course in the database because it doesn't yet exist. Because the truth is, who won this race at times is the event bus. So that data comes all the way across, and for some reason, I'm not actually sure what the details are yet, course discovery hasn't yet finished creating the data on that original call yet. So how do we fix things like this? The way that we did for now, but not the way that I'm proposing that we should do it, is a delay was added on the course discovery consumer, saying like, wait a little bit, please, just to not have this problem. In the future, what I think we will have is the arrow going back to Studio should go away. So why couldn't it go away beforehand? If you were trying to add marketing material for a course, but you had to wait hours or days or weeks for that course data to make it to discovery, you could not do that. So you had to be able to add everything you needed into discovery at once. That is no longer the case. So the event bus is both causing this problem and the ultimate solution to this problem. So now the data is actually flowing across immediately, and we have the option to do things in Publisher like, I'm only going to add marketing material for courses that exist, and go out to Studio if I and create the course first, or to have that micro front end actually call Studio to as a first pass of some wizard, whatever it is, create the course in Studio, and now I'll be able to add marketing data to it. So we want to get rid of this circle. So we talked a little bit about the infinite loops and requests, memcache, idempotence, just spoke about race conditions. There's more things to come. In the how-to, we try to put in like little warnings of you're going to have to think about this, and we haven't been able to think about it fully yet. So one example is schema evolution. We have a lot in there that should help, but it's not fully tested yet. So this is the whole idea of, I have an event now, and I want to change it a little bit. How do I do that and keep consumers and producers happy? Or lifecycle events, what I'm calling lifecycle events, which is like, here's an event for this thing got created, or it was updated, or it was removed, and I want to get them all together on the same topic so that they are ordered correctly versus having them be on their separate topics. And we have notes and thoughts about it, but we haven't done it yet. So these are more to come on this. So next steps, we've got the Redis implementation. So tcrl has a paid for, I can't think of the term for it, funded, thank you. So it's got a funded project going for doing a Redis implementation. And the point of this implementation is there are lots of small to medium-sized deployments of the OpenEdX platform that don't have the same needs that we have, and Redis already is a technology that's a part of the platform. So this will be a simpler deployment, but it's also the Redis implementation, as an example, has capabilities for doing multiple consumers for a topic, but that you can't actually use because those multiple consumers can grab it in any order, where Kafka has capabilities around partitioning and actually keeping things in order and having as many consumers as you have partitions. So I don't want to get into the details, but there's limitations to the Redis implementation, but it should be good enough for many people. We want to move this OAuth to accepted. The main blocker was that the abstraction layer and wasn't proven out yet with multiple technologies. That will be done with this Redis implementation, and then we can accept it. And then more events. So all the names of events that you're seeing here, XBlock deleted, persistent grade summary change, course enrollment, those are all events that already exist in the hooks framework and are already being sent. So the first line of, and there's many more, but these are like actual planned. The first bullet is, I think, planned for like now or in the next week or in the next 2 weeks, like working on getting that into stage at x.org and then out to production for a particular flow, again from studio to discovery. Credentials awarded is another one that's being talked about. I don't think that event actually exists yet, but grades, we've got this, I mentioned already, the whole grades to credentials. There's an existing event, and enrollments, lots of buzz around being able to do things based on enrollments. And then insert your event there. And then there's also, as I mentioned, so much more to learn. So every time we drop one in, it's like, oh, that's an interesting thing, like the Django request versus infinite loop. So there will be more of that. But so many benefits to this. There is a roadmap issue. If you want to get docs, there's pound event bus, Slack channel, reach out, and we can talk. There's also many resources on the next slide. So many documents you can get to. But what did we cover? Why? Hopefully you understand why you are in this room, why we care about the event bus, why everyone else has missed out. We talked about where we're at right now and how to get on the bus, how to ride safely. And yeah, let's open it up for questions. Thank you.
All right, I'm going to try to go up to everyone who has questions and hand you the mic.
So as the bus is based on like Kafka or Redis or something, is there any reason why you would have to use a Django app to consume? Could you just use anything that could consume off the event bus underlying?
So yes, you could use anything to consume. The way these events are being defined are using Avro, as I mentioned. So there's an Avro schema behind each event. And as long as that Avro schema is used, it can be used from any language, from any service. And once you actually have the infrastructure of Redis or Kafka, in theory, if you had third-party systems that aren't even interested in these OpenEdX public signals, in theory, you have the infrastructure and you could just use whatever serialization mode you wanted and plugins for dealing with that and have your own implementation of just, hey, I'm just using the bus because I need to start sending events across. Does that answer?
Yeah. Okay. Yeah. Are there any limits to the size of the data or the frequency of the data on the bus implementation that we have?
Probably. So I think there's, I'm sure there are settings within Kafka about about the size limitations of a particular event, and there's probably just, there's much more to think about if you're actually thinking like, oh, I want to send across this huge piece of data. Does it make sense to send that all within an event, or do I need to like send an event about some data and have callbacks around getting more information? And these are all things that we'll need to think through as we have actual use cases. Is that?
I was wondering what can go wrong in terms of events getting lost. Let's say I have a service that relies on receiving this event. Since the event needs to go send over the network to the event bus, the request could be lost, right? What are the dangers here?
Yeah. So we basically just cross our fingers. No. So it's a great question. So Kafka has, at least for us, I can't speak to Redis, but has a lot built into its code and the consumer code that you actually, the producing code as an example, because you first want to like get it onto the bus, and then once it's there, there's less risk because, as I said, it's there and you can replay it. So they have lots of code for retries and making sure that everything is happy. The first pass that we have for is if there's any error or any problem, we just get it into the logs so that you can get alerted based on the logs. You can replay if there's some temporary problem. But then there's lots of ideas that people have talked about or that you can find on the internet about an outbox or other ideas of saying, oh, we're actually going to, instead of just sending directly to the bus, we're going to send this to a table within the database, and then we have to have now another process that can read through this, get it onto the event bus, and mark it as hopefully sent once it was sent. We don't have that yet, so we don't have that yet.
Can you speak to best practices around topic creation? When should we create a new topic versus use an existing topic? Is there any best practices?
Yeah. So typically, there's going to be a one-to-one relationship between topic and an event type. So each of those like event names that I listed, like for almost all of them, just create the topic for that event type. The life cycle events that I mentioned is where you get into here's a couple of highly related events that could possibly happen on a different server, and we might want to order them, or keep them ordered and have people not have to worry about them getting out of order. And that's the only place. There's actually documentation and a ticket around this exploration, but for a long while, like you could read blog articles and they were like, no, one-to-one was like the only answer, and that, Confluent Kafka has like some blog articles saying, we used to say that, but now we say this for the lifecycle ones.
Yes. So first of all, it's a great move, so we are happy. Have you thought about persistent and non-persistent storage, and is it like part of the consideration? What events needs to be in persistent storage? What events or which topic needs to be non-persistent storage? And like the second question is if you already developed some kind of recovery when like the Kafka is down or when, so yeah.
Got it. So we'll start with the first one. I might have a follow-up question for your question, so before you go too far away. So the persistent storage or non-persistent storage, are you talking about on the consumer? So on the Kafka side, so the way Kafka works, it is persistent, but then there are different settings about how data retention, basically, and do I want that to be persistent for, a week or a day or 2 weeks or infinite? So you can turn that on and say, I'm just going to fill this up for certain use cases and let it live forever, so that I want a new consumer to come up and get all of the data from the beginning. We're not doing that on our one event. We have 2-week retention, I think, right now. But so you have different options at the Kafka layer, and then of course the consumers themselves. Even if you're keeping it at 2 weeks, if you want data redundancy, that's where the consumer would say, oh, I care about this even in the future. I'm going to write this data to my database and keep listening to events to keep my copy. available. And now, time to remember the second question. And it's say it again? Oh, recovery. So for now, it's literally the ability to replay. So if we have, so what I guess we don't have recovery on yet is like publishing problems. So if you're producing an event to Kafka, it has promised uptime. It's got hiccups and retries that it takes care of. So it should be pretty minimal, and we haven't seen anything yet. But at this point, if there were a problem, it would just be in the error logs, and we would need to find a way to do the thing again that fired the event. But the more expected problems are going to be on the consumers, and from there you can actually replay the events that are on Kafka.
All right, that actually cuts us right at time. Thank you all so much. Another round of applause for Robert.
All right, thank you.